Hello viewers, in this video lecture today we are going to talk about the massive open online course on emerging technologies in renewable energy sources. Name of the subject domain is biomass energy, and today we are going to discuss the topic is biofuels. So viewers, here are the important topics which will be discussed in this video. The first is what are biofuels, classification of biofuels, primary biofuels, secondary biofuels, first, second and third generations of biofuels, properties of biofuels. So let us understand what are biofuels. So biofuels are the fuels which are derived from biomass, that is plants or algae material or animal waste. Since such feedstock material can be replenished readily, biofuels is considered to be a source of renewable energy. Unlike fossil fuels such as petroleum, coal and natural gas, biofuels are commonly advocated as a cost-effective and environment-benign alternative to petroleum and other fossil fuels. It particularly within the context of rising petroleum prices and increased concern over the contributions made by fossil fuels to global warming. Many critics express concern about the scope of the expansion of certain biofuels because of the economic and environmental cost associated with the refining process and the potential removal of vast area of arable land from food production. Let us understand the classification of biofuels. Biofuels are categorized based on variety parameters, namely physical state, technology maturity, generation of feedstock. So first we can start classification based on the physical state. Any renewable and biological substance that can be utilized as a fuel, its various raw material can be considered as biofuel and can exist in the following three physical state. The first is solid state. Generally, any solid biomass material can be described as a solid biofuels. Solid biomass is principally any solid feedstock that can be converted into biofuels. Example of such solid biomass include lignocellulose biomass and various types of solid waste. Ideally, these raw solid biomasses can be used directly as solid biofuels or as feedstock for other forms of biofuel production. The second one is our liquid biofuels. It refers to any renewable fuels in liquid form. They are mainly used as transport fuels. Notable examples of liquid fuels are biodiesel, biomethane, bioethanol, biobutanol, biopropanol, biooil and jet fuels. Some of the features and benefits that have escalated research and helped popularize the application of liquid biofuels includes their high combustibility, they are safer and easy to store, they are easy to transport with pipelines, they are safer to transport compared to petrol, they are relatively inexpensive, they have a high energy to mass ratio, their storage stability, they are reasonably non-explosive. The third one is our gaseous biofuels. So biogas, or we can say biomethane, biohydrogen and biosyngas are the commonest example of gaseous biofuels. They have a wide variety of applications including the thermal, transport and heat use and electricity power generations. Over the years, gaseous biofuels have been extensively studied and utilized due to the many benefits derivable from them, which includes higher reactivity. The second is generation of less waste when applied, the fewer oxidants required, the simplicity of the reactors and ease of control. Now we are moving of classification based on technology maturity. According to the degree of technology maturity or status of the commercialization technologies, biofuels are often categorized as conventional biofuel as advanced biofuels. So conventional biofuels are produced through already commercially available technologies. Such technologies continue to be developed for economic viability and profitability. Example of conventional biofuels includes bioethanol, biodiesel and biogas, which are produced through fermentation, transesterification and anaerobic digestion respectively. These technologies have been developed, commercialized and adapted for local or household deployment. Common feedstock for conventional biofuels include sugarcane and sugar beet, corn, wheat, vegetable oil, animal fat, recovered household fat, waste frying oil and others also. The commercialization of these categories of renewable fuel is hampered by high production cost and unprofitable retail prices. The next one is advanced biofuels. The conversion technologies for most advanced biofuels are still generally at the research and development demonstration or early commercial stage. Major examples include hydro-treated vegetable oil, bioethanol, biomass generated esters, microalgae biodiesel and biohydrogen. Bearing in the mind the challenges of shortage of feedstock, the interference of some feedstock with the food chain and the poor cost competitive associated with conventional biofuels, investment in and production of advanced biofuels from inedible feedstock has become an encouraging alternative. However, the adoption and commercialization of advanced biofuels are hampered by poor fuel economy. The next one, classification based on the generation of feedstock. Feedstock for biofuel production are divided into three categories in terms of their generation: the first generation feedstock, second generation feedstock and third generation feedstock. The choice of feedstock has a huge influence on the development and utilization of biofuels as a substitute for FB fuels. Feedstock are chosen based on price, hydrocarbon contents and biodegradability. For example, edible feedstock and those containing pure sugars are relatively expensive. Simple sugars are preferred as feedstock because they are easy to decompose with microbes, while biomasses are selected based on their relatively affordability. The first generation feedstock, the first sets of raw material that were converted to biofuels, are referred to as first generation feedstock. Major example for first generation feedstock includes rapeseed oil, soybean oil, palm oil, sunflower oil, corn, sugarcane, wheat and sugar beet. The extracted oil are converted to biodiesel through the transesterification process, while ethanol, a form of bioalcohol, it is produced from corn, sugarcane and others by direct fermentation. Due to the low production cost, good cost per yield ratio and a large number of carbohydrates in starch or starch for in corn and sugarcane, the use of this feedstock has gained prominence and become an industrial standards. However, the need for large tracts of arable lands to cultivate the plants, deforestation, exploitation of natural ecosystem, bush burning, drastic changes to the ecosystem as a result of increased farming activities, the food versus energy debate and spikes in the prices of the edible oils used for biodiesel are major drawbacks of the use of this generation of feedstock. Also, the feedstock conversion processes are influenced by the physical attributes of the biomass. The products of first generation biogas generates a larger carbon footprints compared to other generation of biofuels. These shortcomings prompted researchers to look for microorganisms and other forms of feedstock to respond to the escalated request for biodiesel and ethanol. Now moving on the second generation feedstock, lignocellulose biomasses are generally referred to as second generation feedstock and are converted to bioethanol and biodiesel. The lignocellulose biomasses are always pre-treated before conversion. For this purpose, 4 pre-treatment processes, namely physical, biological, chemical and combination of this psychochemical and biochemical, are commonly adopted. Apart from the pre-treatment processes, other procedure implemented for the transformation of lignocellulose biomass to bioethanol include hydrolysis, fermentation and distillations. Second generation of biofuels includes cellulose, hemicellulose and lignin. Cellulose and hemicellulose are polysaccharides and are converted to monomeric sugars by fractionalization, while monomeric sugars are used for the production of bioethanol through microbial fermentation. Lignin is a complex aromatic polymers of polyphenols and not only forms a bond between hemicellulose and cellulose, but also function as an obstacle to the of semicellulose and cellulose. Through lignocellulose, biomass does not affect food chain and is seen as an economically feasible feedstock for producing renewable fuels. Its products also has several limitations. The conversion of second generation biofuels suffers from many technical challenges and lacks a mature conversion technology, which makes its conversion uneconomical and unsuitable. Now moving on the third generation feedstock, it originates from non-food sources, algae, which are subdivided into macroalgae and microalgae. It is a large or major example of third generation feedstock. Microalgae are microscopic unicellular photosynthetic microorganism from which a large amount of biomass can be generated. Then from terrestrial plant, they are usually over 400 micrometer in size, between 1 micrometer to 30 micrometer in diameter, and can convert algal biomass, waste and CO2 into diverse bioenergy products by photosynthesis. Microalgae grow rapidly with small quantities of water per kg of biomass. It produces a large number of lipids and starch for biofuel synthesis and are capable of sequestrating CO2 from flue gases. Macroalgae are multicellular marine organism with low concentration of cellulose, levels of structural polysaccharides but no lignin content. Macroalgae, also called seaweed, are capable of growing to up to 60 meter in length. Microalgae are categorized according to their availability, while macroalgae are grouped in terms of their photosynthetic pigmentations. Algal biomass derives CO2 from power plant emission and uses CO2 for its growth. The biomass is converted to CO2 by photosynthesis, which emits oxygen into the atmosphere. The cultivation and utilization of algae as a feedstock for biofuels production is one of the strategies for achieving CO2 mitigation. Algae as organisms that grow quickly in salty water, municipal wastewater and coastline water, and on land that is not useful for farming. Algal biomass can be grown naturally or artificially. The strategies for artificial microalgae and microalgae biomass production include open pond cultivation, photobioreactors and heterophic anaerobic fermentation. Algae has been widely used as a suitable biofuels, or we can say sustainable biofuel feedstock due to its fast rate of acclimatization to potentially challenge environments, the increased popularity of algae based biofuels and the derivatives of other associated bioproducts including natural cosmetics, oils, pigments, pharmaceuticals and nutritional supplements. Let us understand the various properties of biofuels. The main or the following are the sum of the characters of the efficient biofuels, like first is kinematic viscosity, density, calorific value, melt or pour point, cloud point, flash point, acid value, iodine value, cetane number, stability, storage and thermal, carbon residue, ash percentage, sulfur percentage. Now we can understand one by one. That is, the first is kinematic viscosity. Viscosity represents flow characteristic and the tendency of fluid to deform with stress. Viscosity affects injector, lubrication and fuel atomization. Fuels with low viscosity may not provide sufficient lubrication for the precision fit for fuel injection pumps, resulting in leakage or increased wear. Fuel atomization is also affected by fuel viscosity. Diesel fuels with high viscosity tends to form larger droplets on injection, which can cause poor combustion, increase exhaust smoke and emissions. The second property is density. It is the mass of the substance per unit volume. Oils that are denser contains more energy. For example, petrol and diesel fuels give comparable energy by weight, but diesel is denser and hence gives more energy per liter. Biodiesel is generally denser than diesel. Fuel with sample values ranges between 877 kg per meter cube to 884 kg meter cube compared with diesel at 835 kg per meter cube. Thus, density of the final product depends mostly on the feedstock used. The next property is calorific value. It defines at heat of combustion heating value, or heat of combustion is the amount of heating energy released by the combustion of a unit value of fuels. One of the most important determinants of heating value is moisture content. Liquid biofuels, however, have bulk densities comparable to those for fossil fuels. Moving on, the next property, melt point or pour point. It refers to the temperature at which the oil in solid form starts to melt or pour. In case where the temperature falls below the melt point, the entire fuel system, including all fuel lines and fuel tanks, will need to be heated. The next property is cloud point. The temperature at which an oil starts to solidify is known as the cloud point. While operating an engine at temperatures below an oil's cloud point, heating will be necessary in order to avoid waxing of the fuel. The next property is flash point. The flash point temperature of diesel fuel is the minimum temperature at which the fuel will ignite on application of an ignition source. Flash point varies inversely with the fuel's volatility. Minimum flash point temperatures are required for proper safety and handling of diesel fuel. The flash point determines the flammability of the material. Neat biodiesel has a flash point around 150 degrees Celsius, well above the flash point of petroleum based diesel fuel, that is plus minus 70 degrees Celsius. The next property is acid value. The total acid number is an indication of the presence of free fatty acids formed due to oil degradation and combustion. It can also result from improper manufacturing through remaining catalyst or excessive neutralization. The next property is iodine value. It is an index of the number of double bonds in biodiesel and therefore is a parameter that quantifies the degree of unsaturated of biodiesel. It is reported in terms of the grams of iodine that will react with 100 grams of a fat or oil under specified conditions. It is a value of the amount of iodine measured in grams absorbed by 100 grams of given oil. It is commonly used as a measure of the chemical stability properties of different biodiesels fuels against such oxidations. The next is cetane number. It is relative measure of the interval between the beginning of injection and auto ignition of the fuel. The higher the cetane number, the shorter the delay interval and the greater its combustibility. Fuels with low Citin numbers will result in difficult starting, noise and exhaust smoke. In general, diesel engine will operate better on fuels with Citin number above 50. Citin number is usually measured directly using a test engine. Citin test provide information on the ignition quantity, or we can say quality of a diesel. Diesel fuel usually has a Citin range between 45 and 50, while vegetable oil is 35 to 45. Biodiesel is usually having between 50 to 60. Moving on the next property, that is stability. Biodiesel ages more quickly than petroleum diesel fuel due to the chemical structure of fatty acids and methyl ester present in biodiesel. Typically, there are 14 types of fatty acids, methyl esters in the biodiesel. The individual proportion of presence of these esters in the fuel affects the final properties of the biodiesel. Poor oxidation stability can cause fuel thickening, formation of gums and sediments, which in turns that can cause filter clogging and injector fouling. Thermal degradation occurs at high temperature and degrades higher peroxide in the fuel more rapidly than oxidative degradation. Biodiesel and biodiesel blends are much more thermally stable than diesel. Biodiesel and its blends should not be stored in a storage tank or vehicle tank more than 6 months. Depending upon the storage temperature and other conditions, suggest the use of appropriate antioxidants. The next property is carbon residue. This indicates the tendency of fuel to form carbon deposits in an engine. An important indicator of the quantity or quality of biodiesel is the carbon residue, which correspond to the content of glycerides, free fatty acids, soaps, polymers and remaining catalyst. Next is ash percentage. It is a measure of the amount of metals contained in the fuel. High concentration of these materials can cause injector tip plugging, combustion deposits and injection system wear. The ash contents is important for the heating value. As heating value decreases, the increasing ash contents. Ash contents for biofuels is typical lower than for most coals, and sulfur content is much lower than many fossil fuels. Sulfur percentage. The percentage by weight of sulfur in the fuel sulfur content is limited by low to very small percentage for diesel fuel. It is used on road applications. First use vegetable oil and animal fat based biodiesel has been less than 15 ppm sulfur. Many researchers claim that pure biodiesel is essentially sulfur free and therefore biodiesel is an ultra low sulfur fuel. Now moving on the application of biofuels. Biofuels have a wide range of application. The first, we can say transportation. Biofuels can be used as a substitute for gasoline or diesel fuel in vehicles. They can be used in existing vehicles with minimum modification, and they can help to reduce greenhouse gas emission. The next application is electricity generation. Biofuels can be used to generate electricity in power plants. They can be burned directly or they can be converted into biogas or bioethanol, which can be used to generate electricity. The third is heating. Biofuels can be used to heat homes and businesses. They can be burned directly or they can be converted into biogas or bioethanol, which can then be used to heat water or air. The next application is cooking. Biofuels can be used for cooking also. They can be burned directly or they can be converted into biogas or bioethanol, which can then be used to cook food. The next application is industrial application. Biofuels can be used in a variety of industrial application such as manufacturing, agriculture and construction. They can be burned directly or they can be converted into biogas or bioethanol, which can then be used in industrial processes. Other applications, biofuels can also be used for a variety of other applications such as cleaning oil spills, producing lubricants, and making plastics. The specific application of biofuels will depend on the availability of feedstock, the cost of production, and the environmental regulations in the region. However, biofuels have the potential to play a major role in reducing our reliance on fossil fuels and combating climate change. Here are some of the most common type of biofuels and their applications. Ethanol. It is a biofuel that is produced from corn, sugarcane, and other crops. It can be used as a substitute for gasoline in vehicles, and it can be also be used to make alcoholic beverages. Biodiesels. It is a biofuel that is produced from vegetables, oils, or animal fats. It can be used as a substitute for diesel fuel in vehicles, and it is also a good lubricant. The next is biogas. It is a gaseous biofuel that is produced from the anaerobic digestion of biomass. It can be used to generate electricity, heat homes, and cook foods. The next is hydrogen. It is a clean burning fuel that can be produced from biomass. It can be used in fuel cells to generate electricity, and it can also be used to power vehicles. The use of biofuels is growing rapidly, and it is expected to continue to grow in the coming years. As the technology continues to develop, biofuels are becoming more affordable and efficient, making them a more attractive option for transportation, electricity generation, and heating. There are many reasons why we need biofuels. Here are some of the most important ones to reduce our reliance on fossil fuels. Fossil fuels are a finite resource that is becoming increasingly inexpensive and difficult to extract also. Biofuels, on the other hand, are renewable and can be produced from a variety of sources such as corn, sugarcane, and wood. To combat climate change, biofuels produce fewer greenhouse gas emissions than fossil fuel. This is because the carbon dioxide that is released when biofuels are burned is the same carbon dioxide that was absorbed by the plants that were used to produce the biofuels. To improve energy security, biofuels can help to reduce our dependence on foreign oil. This is because biofuels can be produced domestically from a variety of sources. To create jobs, the production and use of biofuels can create jobs in the agricultural, transportation, and energy sectors. To improve air quality, biofuels can help to improve air quality by reducing emissions of pollutants such as sulfur dioxide, nitrogen oxide, particulate matters, and others also. Overall, biofuels have the potential to make a significant contribution to reducing our reliance on fossil fuel, combating climate change, improving energy security, and creating jobs. As the technology continue to develop, biofuels are likely to become even more important in the years to come. Here are some additional benefits of biofuels, like it can help to reduce rural poverty. The production of biofuels can create jobs in rural areas, which can help to reduce poverty and improving the standard of living. It can help to protect the environment. It can help to reduce deforestation and land degradation, as they can be produced from agricultural waste and other non-food crops. It can help to improve food security. It can produce from food crops, but they can also be produced from non-food crops. This means that biofuels can be produced without competing with food production. Despite the benefits, there are also some challenges associated with biofuels. These challenges includes the production of biofuels can have a negative impact on land use and water resources. If biofuels are produced from food crops, it can lead to deforestation and land degradation. If biofuels are produced from non-food crops, it can lead to competition for water resources. Overall, biofuels have the potential to be a valuable part of the energy mix. However, it is important to carefully consider the challenges and potential risks associated with biofuels before making a decision about their uses. Now let us understand how energy can be obtained from biomass. The three main processes by which energy can be obtained. from biomass. The first one is direct consumption by burning solid fuel to power generation. The second is bacterial decomposition, which is also called anaerobic digestion. In this process, bacteria digest wet waste without being exposed to oxygen to create methane gas. And third, conversion to liquid or gaseous liquids, fuels. Both direct consumption and bacterial composition make energy that can be used to generate heat to power generators. To make biomass into liquid or gaseous fuels, biofuels must be converted from their original forms. The most basic way to do this is through fermentation of crops that are high in sugar or fat into ethanol, which can be mixed directly with gasoline to power cars. Pyrolysis, in which biomass is broken down without oxygen to make bio-oil and biochar. The next one is hydrothermal liquefaction. In this, wet biomass such as algae, sewage or a liquid slurry of feedstock to make bio-oil. Gasification, in this biomass is cooked at a high temperature in the presence of oxygen or steam to make hydrogen gas, and then cleaned up the conditions to make it into a usable fuel. Moving on the next, the biofuel advantages. It can renewable energy sources, lower greenhouse gas emissions than fossil fuel. It can be produced from a variety of biomass feedstocks such as corn, sugarcane and wood. It can be used in existing vehicle and infrastructure. It can help to reduce dependence on foreign oil. The next is disadvantage of this. It can have a negative impact on land use and water resource. It can be more expensive than fossil fuel. It can require significant upfront investment. It can be less energy efficient than fossil fuel. Now we are comparing this biogas advantages. The first, renewable energy sources, lower greenhouse gas emission than fossil fuel, does not require land for cultivation. It can be used for electricity generation, heating and cooling. Can be upgraded to produce biomethane, which is a clean burning fuel that can be used in natural gas pipelines and vehicles. The disadvantage of this is it can be produce air pollution if not properly managed, can be more expensive than fossil fuel. It can require significant upfront investment. It can be less energy efficient than fossil fuel. Here we are discussing some additional consideration are biofuels and biogas. So in the biofuels, the production of biofuels can have a negative impact on land use and water resources, especially if it is produced from food crops. Biofuels can be more expensive than fossil fuel, especially if it is made from non-food crops. The upfront investment in biofuels production can be significant. Biofuel can be less energy efficient than fossil fuel. Despite the challenges, biofuels and biogas are both promising renewable energy sources that have the potential to reduce our reliance on fossil fuel and combat climate change. As the technology continues to develop, these sources of energy are likely to become more affordable and efficient, making them even more attractive options for the future. Thank you so much for watching this video.